Welcome to aminacademy.com. In heat and mass transfer, let us discuss about general heat conduction equation in Cartesian coordinates. Look at this. Consider an infinitesimally rectangular parallelepiped, that is a small elemental volume having sides dx, dy and dz in Cartesian coordinate x, y, z. Let dt by dx dt by dx is temperature changes, tem temperature, rate of temperature change, rate of change in x direction. Then you can say dou t by dou x into dx is change of temperature through distance x. Through distance dx. Then further, and you can say t plus dou t by dou x into dx temperature on the right face. On right face, right face that means right face of EFGH. Look at here this elemental area. Here at the face ABCD, the temperature change is temperature in left side is T plus dou T by dou x and dx. At same time, this right side is T plus dou T by dou x dt. Here dou T by dou x dx. Here T plus dou T by dou x dt. Similarly, you can write all directions now. Similarly, for y direction is t plus dou t by dou y into dy, and z direction is t plus dou t by dou z dz. Further, let kx, ky, kz are thermal conductivities. Thermal conductivities of along the material in x, y and z direction. Now If the directional characteristics of a material are equal, if it is same, then it's called isentropic material, and if it is unequal, it is called an isentropic material. For isentropic material, let Qg Qg equal to heat generated per unit volume by unit volume per unit time. Next, here let Q equal rate of heat flow, rate of heat flow in a direction, and Q days equal, that is Q into dou tau, is total heat flow. Total heat flow, that is, we can let it heat flux. It is flux in the direction at time dou tau. In time dou tau. Now, net heat accumulated in the element due to conduction of heat from all direction is considered. Now we'll consider first part, net heat accumulated in the element due to conduction of heat. Due to conduction of heat from all the direction considered. Heat conducted, conduction of heat from all the direction is considered. Therefore, heat influx is, we can write in Q days in x direction. Let it be Qx days is minus Kx, heat conductivity through x direction, and dy dz dou t by dou x dou tau. During the same time interval dou tau, the heat flow out the right phase. Here, heat flow influx in this direction. At the same time, heat out in this direction, that is perpendicular to the phase FEGH, and that we can write Q dash x plus dx is equal Q dash plus dou by dou x Q dash x dx by using Taylor's expansion. By Taylor's expansion, we get this one. Now, therefore, heat accumulation, net heat accumulation due to heat flow in x direction is that is dq dash x equal q dash x minus q dash x plus dx. Already we have this one, q dash plus we have here this one, this q dash x dx is this we are using here, that is dou by dou x qx dash dx. That means we are getting here q dash x is dq dash x is subtraction of q dash x minus q dash x plus delta x. Then this, after simplifying, we get minus dou by dou x q dash x dx. Further, we are substituting dou by dou x, and to q dash x we can substitute, that is minus kx dy dx dou t by dou x into dou tau. Here dy dz here and dx. Similarly, heat accumulation, let it be here 1. Similarly, heat accumulation due to heat flow by considering x and y direction. Similarly, y and z direction is considered. We have dq dash y equal dou by dou y of ky minus minus become plus here. So ky dou t by dou y into dx dy dz, because we are multiplying dy dz dx, that it becomes here. Then with dou tau, let it be 2. Then similarly dq dash for z equal dou by dou z kz dou t by dou z dx dy dz dou tau This is a 3. Now net heat accumulation. Net heat accumulation in the element due to conduction of heat from all direction, all coordinates by all coordinates by through all coordinates is equal dou by dou x kx dou t by dou x into dx dy dz for same for y dou by dou y ky dou t by dou y into dx dy dz plus dou by dou z kz dou t by dou z dx dy dz. Everywhere dot comes. Dot. Now here, now we are taking some common factors, that is dx, dy, dz dot tau. So we can write this as dou by dou x kx dou t by dou x plus dou by dou y ky dou t by dou y plus dou by dou z ky dou t by dou z. This all is multiplied the common factor of dx, dy, dz and dot tau. Here this is the means we arrived that heat total, that means net heat accumulation. This equation is net heat accumulation. Now next is we'll consider the second part of total heat generated within the element. Total heat, this is make it 4. Heat generated, total heat generated within the element. Within the element, that is we can use it Q dash Qg dash, total heat generated within the element. So for that the formula is Q G dash equal Qg for a small elemental Qg dx dy dz dot tau. Next, energy stored in element. Third, energy stored in the element is the formula is rho, that is density, dx dy dz, that is volume, into coefficient of that is c, then dou t by specific heat constant Cp. We can put C only, specific constant C, and dou t by dou tau into dou tau. So we are having this, when we are having rho, now we are equating this phi. Therefore, now substituting the equation this in the first one. First one we are having this. Therefore, total we are getting now dou by dou x of kx dou t by dou x plus dou by dou y ky dou t by dou y plus dou by dou z kz by dou t by dou z, and plus heat generated, that is Qg equal rho C dou t by dou tau. Here, after simplifying this one, that means we are every terms we are having dx dy dz, so we are cutting both sides, and which gives simplified form this. This is the general heat conduction equation. This is general heat conduction equation in Cartesian coordinates. Now next, if thermal conductivity is same, conductivity is same in all direction, that is we can put it K equal Kx Ky Kz, then this equation become further simplified, that we have then after simplifying we'll get dou square dt by dou x square plus dou square t by dou y square plus dou square t by dou z square plus qg over k, because we are taking k out and cut, but this side we have to introduce the reciprocal k, equal rho c rho c by k to dou t by dou tau, which is equal 1 over alpha into dou t by dou tau, where alpha equal k over rho c, that is diffusivity. Thermal diffusivity is called thermal diffusivity. This time alpha is k over rho c is called thermal diffusivity. Now this equation become further simplified by using this thermal diffusivity as well as multiplying that here dou by dou x into dou t by dou x is dou square t over dou x square. Like this, every terms will be simplified. We have done. Please subscribe our YouTube channel.